Hello, I'm Doug Love from Applied Search Technology, and I'm going to talk about getting started with CADFIND3D and show you how simple and easy it is to use. But first of all, I just need to sort my desktop out for the demo, so I'll move the slide over here. And the other thing I'll do is open SOLIDWORKS, and that's because CADFIND is integrated into SOLIDWORKS or uses SOLIDWORKS, and therefore you need to have a copy of SOLIDWORKS on your machine. In this case, the current version of SOLIDWORKS, which is 2016. Now I've just loaded up the free version of CADFIND, and the free version is intended for people to evaluate the system and to use it in small applications, and therefore we supply it with a demonstration catalogue, which is what I'll open first. The demonstration catalogue is a little constrained in that the user can't add new parts or delete any of the parts that are in it. If you want to do that, then you can switch to your own catalogue, which we supply pretty well empty, and you can add parts to your heart's content, or rather up to about 1,000. I think the current limit is 1,100. The system will let you put 1,100 parts in here, and you can search it and do whatever you wish, but beyond that you'd have to switch to a different version of the system. I'll go back to the demo version now to talk a little bit about the user interface. The system displays all the parts in the catalogue in this panel-like fashion, and you can page down, work your way through the catalogue if you want to. You can highlight a part, perform a search, and the system will, instead of displaying part number order, it'll display in similarity order. So the system thinks these two parts, or this part, is 83% similar to this one. But that search was done within this demo catalogue, which is about 1,000 parts. So I thought for the purposes of the rest of this demonstration, perhaps use a bigger catalogue, and that means I have to load the next version up of CADFIND, which is the CADFIND master system. This is a licensed version. CADFIND remembers what catalogue you last used, and that's why it's opened the demo again. Notice it didn't give us the choice of just the two catalogues. That's because we can open any number of catalogues here. I'll open this read one. But I can also open any number of catalogues at once. So I've got the user one, 3D demo, or the new one, the read one. This catalogue has 4,000 parts, rather more, and is perhaps more representative of the sort of thing that smaller companies use. You can have up to 100,000 parts in a catalogue still have reasonable search performance. Obviously the number you do have depends a bit on how you want to split your catalogues up. But, anyway, this catalogue has 4,000 parts, and so I thought I'd show how it performs in typical text and shape searches with that number of parts. Of course, the way that people would traditionally search for parts is using text, and CADFIND supports that. So we can do a search if we want to on the description of the part or on the part number itself. I'm going to cheat a bit and look for a part number that I know is in the catalogue. So if I click the search button, the system will come up with, here we are, ABC1T. That's given a 100% score on the similarity index that CADFIND calculates, because it's an exact match to the text that I typed in. I could have put wildcards in and so on, of course, to make the search more flexible, but and you can see that these parts get slightly lower scores because they've got one character different. Text searches can be effective, but they depend greatly on the accuracy of the description, and some descriptions are very generic. You know, if something called a bracket is likely to be loads of parts in the company's database called bracket, and there will be many different shapes and sizes of bracket. So searching on the description is often not effective because of the ambiguity of the definitions that people have to use. If you're going to search though on the geometry of the part, on the shape and the size, then of course that isn't ambiguous. We can remove that ambiguity. What we need though is a system that is fast in doing that. So if I highlight this part again and this time search using its shape and size, that search then was 4,000 parts. So the system just went through 4,000 parts looking for ones which are similar. And what it's come up with is a number that it thinks are quite similar. The green highlighting indicates that these parts all have similarities that CADFIND thinks is better than 70 or better on its calculated similarity index. It's a nominal scale. It doesn't 100% doesn't mean perfectly identical, but it means very, very similar. The way that you'd examine them is, of course, what you'd want to do is look at them in your CAD system. So if we right click, I can load the part into SOLIDWORKS. There we go. And I'll load this second one as well. And while I'm at it, I'll load the third one. And if I tile these and then tidy this display up a bit, right, this was the part that we were using as our master, or the one that we wanted to match against. So what we were looking for were parts like this one. This is the one with the highest score, 96, and you can see actually it's remarkably similar. The shape, all the shapes are similar right through the part, and it's likely that the only difference, the reason it didn't get 100%, is that the size is slightly different. Some dimension somewhere is a bit different. But you'll notice this item, which got 86, quite a bit lower score, is different, maybe because of size, but almost certainly because there is no through bore. So you can see in these parts, these two both have through bores, this one doesn't. And that illustrates how CADFIND works, that what it's looking for is a match on the shapes but also on the size. So it's that combination of the two which makes CADFIND very effective at finding matches. Of course, it's not always the case that you want to search, excuse the sound, that you want to search within from within CADFIND. It's actually quite a lot more likely that you would want to search from within the CAD system itself. So if I just go back to my examples, of course we might have right. So I've loaded a part which is a completely detailed part. Maybe a customer has sent us a model of the part that they want us to supply, and we want to see whether we've got anything in our database like it. So we want to search our catalogue using this model. System works in much the same way. You click a single button, it searches through the database looking for matches in just the way it did when we did the one just now. And you can see that there is a perfect match. There are also a number of parts which are not perfect matches but pretty close. In fact, the whole page looks pretty close. The only issue with this is that this is a detailed part, and if the part didn't exist already and I was having to create that in order to do the search, that would of course be rather inefficient, to say the least. So it's worth noting that CADFIND can also operate with simple models. So in this case we have a very simple model. We search in exactly the same way, click the same button, and this time the system has come up with some matches. Now these will be closest to what CADFIND thinks the geometry of this simple model are, because it may not be the case that that is actually the part we want. It may be that this one down here is the nearest on that page, or maybe we might have to go to another page. If we highlight that one that looks like the best match so far and click a search within the catalogue, you can see it then picks up a whole load of other ones that may be suitable. And as before, we can load them back into the CAD system to see whether they are. Coding of parts themselves, adding new parts to the database, is actually very similar to the searching. We basically load the part. Let me just go back to my coding example. Here we are. And this time we don't do a search, but we do add. CADFIND examines the part, extracts information about its shape and its dimensions and so on, and then adds that into the catalogue. That means that this part could be loaded back into SOLIDWORKS at some subsequent date if we want to, or we can use it for searches, or of course it can be found by searches. In this case, once it's added the part, it also does a quick search for anything that's like it, to see if there is anything that's like it already in the catalogue, and this time it actually has found something. So if we expended a lot of energy drawing this part, we didn't need to. We could have simply used QK5. And that in a way is the essence of reuse. That is, we need to be able to find whether there's an existing part that we can use as it is, or whether we need to make some minor modifications to be able to reuse it. Okay, well, I think that's essentially it. That's the basics of using CADFIND. That's opening a catalogue, adding parts into a catalogue, searching it either from within the catalogue itself or from the CAD system, and then looking at loading it back for reuse or standardization. Okay, thank you.